Hello everyone and welcome to Instant Biology by Dr. Neelab. I am here with you again with a very important topic, and the name of the topic that we are going to start today is enzymes. Now you would be knowing that enzymes topic is asked in different life science examinations like GATE, BT, Excel, CSIR, DBT, JRF, ICMR, etc. And in today's lecture, I would be focusing upon all the important aspects of enzyme, starting with the basic concept of what is an enzyme. Then we would be progressing with what is the mechanism through which the enzyme functions. Then I would be dealing with the classification of enzymes, and also finally I would be dealing with some of the PYQs that have been asked in CSIR net and other examinations. So without much ado, let us start what is enzymes. This lecture would be completely in English. For those of you who understand Hindi better, I've already made a lecture on enzymes in Hindi. The link to the same would be available at the last of the video. You can go and check that out as well. So without much ado, let us start what is an enzymes or what are enzymes. So on the first screen, you would be seeing the question, what are enzymes? We are starting with the question, what are enzymes? And now I'm showing you the answer to this question. Now you can see an enzyme, if I define an enzyme, so enzyme is a biocatalyst. Remember that the term biocatalyst actually represents the enzyme. You might have already heard about the term catalyst. You might have already heard about the term catalyst. Now catalyst term or catalyst is generally used in chemistry or chemical reactions, but for our purposes since we are studying with respect to enzymes, and enzymes are functional in biological reactions, so that is why we are using the term biocatalyst over here. Biocatalyst means an enzyme or a catalyst that is more prevalently or more commonly used in biological reactions. Okay, so biocatalyst increases the rate of chemical reactions, and this chemical reaction is majorly biological. That means happening inside the cells. When we just say chemical reactions, it is more of a catalyst. But when you are talking about the cells or the reactions that are taking place inside the cells, then you are using the term enzymes. Enzymes is a more common term, or biocatalyst is the same term. It's synonym of enzymes. Now, does not get changed in the process. What does this mean? You would be knowing that enzymes does very magical things, that it proceeds, or it accelerates a reaction. But always remember that an enzyme will not get changed in a process. Now whatever enzyme or whatever amount of the enzyme that you are using, or you started with a particular quantity of the enzyme, the same quantity will be available at the end of the reaction also. For example, there is a reaction. Let me just draw a reaction over here. So suppose A is getting converted into B, and the enzyme that we are using over here is, let us say, E1 enzyme. Now let us say that E1 enzyme, let us say some quantity of E1 enzyme you were using, let us say X quantity of E1 enzyme you were using in this reaction, you started using in this reaction, but at the end of the reaction also you would get the same quantity of the enzyme. No amount of the enzyme will be used up in a reaction. So you would get the entire quantity back at the end of the reaction, because yes, the enzyme will be taking part, but it will not be consumed in a reaction. Next, virtually catalyzes all cellular reactions. Now this is a very important part that you should be knowing. All the biological reactions, or all the reactions that are occurring inside cells, they essentially utilize some or the other enzyme. Why? Because the reactions that have to be performed inside the cell have to be extremely fast. In general, I am talking about that most of the reactions that are occurring inside the cell are fast in nature. If you are not using an enzyme, then the reaction will not be accelerated, or the reaction will not attain the desired speed. So the function of the enzyme is to give the proper speed, or to allow the reaction to attain the proper speed. I'll give you an example over here. Now suppose you are riding a bike, or suppose you are driving a car, and suddenly you see a truck in front of you. What will you do? You will press the brakes. How did this happen? There was a chemical reaction happening inside your system that signaled that yes, there is a truck in front of us and we should press the brake. This reaction has to be extremely fast, otherwise the consequences can be lethal. Therefore, the reactions inside the cell have to be extremely fast, and in order to facilitate the reactions happening at this speed, enzymes have to be used. That is why I have written virtually catalyzes all cellular reactions. Okay, now let us move on to the next concept. The next question is, what are the properties of the enzymes? So we started with enzymes. What are enzymes? We have discussed basically the different types of enzymes. We have talked about the different, we have defined the enzymes with its broad properties. Now let us go into the depth of the different properties an enzyme possesses. So the first thing is, enzyme possesses the following properties. We would be discussing each and every property in some depth over here. Most enzymes are proteins. Now this is again a very, very important point. The term most is important over here. Most enzymes are proteins. This means that not all enzymes are proteins. Roughly saying that 99% of the enzymes that you would be watching, 99% of the enzymes will be proteins and 1% of the enzymes will not be proteins. Now you will ask me that which enzymes, or I mean, when you say that 1% of the enzymes are not proteins, what do you want to say? What is the nature of those enzymes if they are not proteins? Understand this, that exception for this statement is most enzymes are proteins. The exception to this statement is some small group of catalytic RNA molecules. So this answers our question that what would be the nature of such biomolecules that are not proteins but they have the enzymatic feature. So these molecules would have RNA type, or they would be RNA in nature, right? So important point is that most of the enzymes are proteins, but roughly around 1% of the enzymes have RNA nature. Okay. Now, the next important point is high specificity. What does this mean? Enzymes have extremely high specificity. This means that if a reaction is occurring in which A substrate is getting converted into a product B, let me just draw it over here so as to make you understand. Suppose in a reaction, this reaction is occurring, A is converted into B, okay? And let us say again the enzyme E1 is functioning over here. And there is another reaction, let us say C is converting into D. Now this reaction as enzyme E1, it will not happen that E1 will be catalyzing this reaction also. Therefore, what I want to say is enzymes are extremely specific in their function. They would be catalyzing a specific reaction and they would not be involved in catalyzing other reactions. So this is the specificity. For instance, if you study glycolysis or if you study other biochemical reactions, you would know that each and every reaction has a specific enzyme. You would not see that multiple reactions are being catalyzed by only one enzyme. That is not seen. So the reason behind this is the specificity of the enzyme. So enzymes are specialized proteins and they would be catalyzing particular reactions only. Next point is enormous catalytic power. What do you mean by this? Enormous catalytic power. When I say enormous catalytic power, I want to say that the rate of the reaction would be enhanced massively. If I say that the rate of the reaction is enhanced by around 10 to the power 5 to 10 to the power 7 times, this is the rate, this is the increase in the rate of the reaction that you get when you are using enzyme in comparison to when you are not using enzyme. So what do I, when I say increase in the rate of the reaction, what do I want to say? Now suppose I am at Delhi, okay? Suppose I am at Delhi, okay? And I want to go to Mumbai. I am at Delhi and I want to reach Mumbai. What options do I have? How can I reach to Mumbai? So there are several options that I can take. I can take a flight, I can take a train, I can take my own car or bus. So these are the options, general options that I would be having. But suppose that if I am in a hurry, I would definitely use a flight. Why? Because flight will reduce my traveling time by a great extent. The same thing is happening over here. If you are using an enzyme, the time that you would be requiring to reach the equilibrium decreases considerably. Now suppose a reaction was reaching to equilibrium in, let us say, 10 minutes without an enzyme. A reaction was reaching to equilibrium in 10 minutes without an enzyme, and suppose you are using an enzyme now, so what might happen is that the time to reach the equilibrium now becomes 1 minute. This is the difference that you would be getting when you are using an enzyme in comparison to when you are not using an enzyme. Okay, now let us come back to what we were discussing. So enormous catalytic power simply means that the rate of the reaction would definitely increase. So increased rate of reaction, let me just move so that you can check out what I have written. So enormous catalytic power means lowers activation energy and increases rate of reaction. When I say lowers activation energy, what does this mean? I would be talking about this in just a moment. Okay, so lowers activation energy I would be talking about, but up till now you would have understood that it increases the rate of the reaction. The rate of the reaction is increased. Now, when I say lowers activation energy, I simply want to explain it to you that, let me just draw it over here. Okay, now suppose this is the energy of a substrate and this is the energy of the product. Okay, and this is over here the transition energy. What do I want to say over here? I simply want to say that only those substrate molecules will be converted into product that have this much amount of energy. Let us say energy 1. So the substrate molecules that are having even amount of energy, only those substrate molecules will be converted into product, because they have to cross this energy barrier. This is an energy barrier over here, so this has to be crossed. So only those substrate molecules that are having this much amount of energy will be converted into products. Now let us say we started with 100 substrate molecules. Now obviously out of 100 substrate molecules, very few substrate molecules will be having this even amount of energy so that they can get converted into products. Let us say only 5 molecules out of 100 were having this even amount of energy. Now, obviously, if only 5 molecules are substrate are taking part in the reaction, then obviously the speed of the reaction will be extremely slow, or the rate of the reaction will be extremely slow. If I want to enhance the speed of the reaction, I would be putting enzymes into it. What will be the functionality, or what will the enzyme do? Enzyme will reduce the activation energy to something like this. That means previously the activation energy was this much. This was the activation energy. What do you mean by activation energy? Activation energy is the energy that is required. Activation energy is the energy that is required by the substrate to get converted into product. And if I want to say that, if I want to enhance the rate of the reaction, obviously I would be requiring the activation energy to be lowered down. So activation energy now, when you are using an enzyme, lowers down, it decreases, the activation energy decreases. Activation energy decreases. Previously it was big, now the activation energy has decreased, because of which more substrate molecules will be taking part in the reaction. Let us say previously only 5 substrate molecules were taking part in the reaction. Now let us say 50 substrate molecules are taking part in the reaction, and because of this, due to this, what will happen? The speed of the reaction will enhance many folds. The speed of the reaction will be increasing it would be increasing greatly. That is why the enzymes play such an important role in enhancing the speed or enhancing the rate of the reaction, because they allow more substrate molecules to take part in the reaction by decreasing the activation energy considerably. So this is what is happening. So this is what I meant by activation energy. Okay. So this point is complete. It lowers down the activation energy. Hopefully you would have understood this point, and ultimately it leads to an increase in the rate of the reaction. Now, it does not change equilibrium state of a biochemical reaction. Now this is again a very important point, and obviously students get confused over here. What I want to say over here is, does not change equilibrium state of a biochemical reaction. That means it will have no effect on equilibrium constant. No effect on equilibrium constant. What do I want to say over here? Let us understand this. That suppose a reaction A is getting converted, a substrate A is getting converted into B, and this reaction is reversible. Let us say that the rate of the forward reaction is 10 and the rate of the backward reaction is 2. Rate of the forward reaction, I'm just writing it over here, rate of forward reaction, and this is rate of backward reaction. Now, if I say K equilibrium, what will be the K equilibrium of this reaction? Rate of forward reaction upon rate of backward reaction. This would be equal to 10 by 2 equal to 5. So rate of forward reaction upon rate of backward reaction over here will be 5. Now, if I say that we are using an enzyme, over here no enzyme was used. But suppose in the next reaction I want to use an enzyme, the same thing. So when you are using an enzyme, the rate of the forward reaction as well as the rate of the backward reaction are increased. Many students do not understand this. They only think that the enzyme will be affecting the rate of the forward reaction, but this is not true. The enzyme will be affecting both the reactions. That means it will be affecting the forward reaction as well as the backward reaction at the same, and will be having the same impact on both of them. Let me just draw it. So suppose A is getting converted into B. Remember that over here we are using enzyme. Enzyme is present. Now over here this was 10 and over here this was 2, and suppose I am saying that this enzyme is impacting both forward and backward reaction. Let us say it is increasing the forward reaction and backward reaction, let us say by 100 times. So forward reaction was 10, backward reaction was 10. I will be multiplying it by 100 over here and 100 over here, because the impact will be same on both the reactions. So 100 and 100 would be cancelled out, and again you would be getting 5. This actually proves that there will be no effect on the equilibrium constant, or the reaction will have no impact on K equilibrium, of the enzyme will have no impact on K equilibrium. Remember this. Now, let us move on to a more important concept, a further important concept, and we are going to talk over here about classification of enzymes. What do you mean by classification? Now this has been asked in different life science examination and is important, and often students find this confusing. But if you listen to me, I will be explaining it in easy language and you would be able to follow everything. Now let me just classify the enzymes according to the composition. Now firstly, this is your enzyme. This is what we are talking about. Obviously we have already said that enzymes either can have a proteinaceous nature or can have RNA nature. So 99% of the enzymes are having proteinaceous nature, and only 1% of the enzymes are having RNA nature. Now this again is extremely important point. Remember that the enzymes that have RNA nature are called as ribozymes. Let me just write it down over here also, that the enzyme that is having RNA nature would be called as ribozyme. So this is called as a group of catalytic RNA molecule, and these are called as ribozymes. One more important aspect I would want to share over here is that if RNA, there is a theory that that says that in the initial times when the life was originating on Earth, RNA was only present and there were no proteins. RNA was only functioning as an enzymatic form at that particular time. But since RNA does not have or did not have that much specificity at that time, so it was a non-specific molecule, and the rate of the reaction was not enhanced up to the mark that one would have wanted. That is why gradually there was an evolution of another molecule, and then proteins came up, and proteins started actually taking the work of enzymes, and therefore now most of the enzymes have proteinaceous nature, and around 1% or less than 1% of the enzymes have RNA nature. So this is what we say, or this is what the theory of RNA says. Now let us come back to the concept. So ribozyme, I wanted to add 1% of the enzymes are RNA, and they are called as ribozymes. Now proteins can be divided into two parts. I mean to say, when the proteins are functioning as enzymes, we can classify them into two parts. First one is simple enzyme, and the second one is conjugate enzyme. In case of simple enzyme, only proteins are present, only proteins. Only proteins. Now you would get a better understanding of this when we start talking about conjugate enzymes. So in simple enzymes, only protein is present, but in conjugate enzyme, there are two components. What are the two components of conjugate enzyme? The two components are non-proteinaceous part and proteinaceous part. Now this might be confusing to you. Let us understand this again. So a conjugate enzyme is actually made up of two components. Conjugate enzyme is actually made up of two components. The first component is your normal protein, But this protein will not be able to function alone. Therefore, it requires another component, but this component is actually non-proteinaceous. What is it? Non-proteinaceous. So this is the second component, non-proteinaceous. So non-proteinaceous component is called as cofactor. Non-proteinaceous part is called as cofactor, and proteinaceous part is called as apoenzyme. Apoenzyme. Now this is extremely important. Please remember this. So non-proteinaceous part, let me write over here also, it is called as apoenzyme, and the proteinaceous part is called as the proteinaceous part is called as apoenzyme, and the non-proteinaceous part is called as cofactor. Okay, so remember this, cofactor and apoenzyme. This is the same thing that I have talked about over here. Okay, now proteinaceous part we already know. Now talking about non-proteinaceous part, because this is having a variations. As I've said, non-proteinaceous part is called as cofactor. Now this cofactor can be of different types. The first type is metal ion. That means over here the non-proteinaceous part will be in the form of metal ions. Now metal ions again can be further subdivided into metal activated and metalloenzymes. Metal activated and metalloenzymes. We would be coming back to this in just a moment. And the next thing is, that means this is a metal ion, that means it is a inorganic part. Inorganic. And the next one is coenzyme. Coenzyme is the organic component. Let me just make you understand this again. I said that non-proteinaceous part is also called as cofactor, and this cofactor can be of two types. Cofactor can be of inorganic type, that example is metal ions, and it can also be of organic type, and the example is coenzyme. Now I have seen many students getting confused between cofactor and coenzyme. There is no confusion in this actually. There is a very vast difference. Cofactor is a larger term and coenzyme is just a type of cofactor. When the cofactor is having organic nature, then the cofactor is termed as coenzyme. When the cofactor is having an inorganic nature, it can be classified as metal ions. Now further, coenzymes which are organic in nature can be subdivided into prosthetic group and co-substrate. Prosthetic group and co-substrate. Prosthetic group and co-substrate. So I believe you would have got a clear idea. I would be talking about all of this classification in detail in just a moment. I just wanted to give you an outline of this so that you can get a better idea. Okay, let me just go through this again. First of all, we said that the enzyme can be of two types. It can have two nature, protein and RNA. Protein nature, RNA nature is as such. Protein can again be subdivided into two types: simple protein, conjugated protein. Simple protein is again, it is only having proteinaceous part. Conjugated protein is having two parts. It is having the proteinaceous part and the non-proteinaceous part. Non-proteinaceous part can be subdivided. Non-proteinaceous part is called as a cofactor. It can be subdivided into two parts. First is if it is having an inorganic nature, it is called as metal ion. If it is having an organic nature, it is called as coenzyme. Metal ions can be further divided into metal activated and metalloenzymes, and coenzymes can be subdivided into prosthetic groups and co-substrate. I hope you got a clear idea. Now let us move forward with the next thing. Now, as I've already said, that simple enzymes are, as the name suggests, they are having amino acids only. That means they have the proteinaceous part only. But if I'm talking about the conjugated enzymes, as I've said, conjugated enzymes are made up of two things: proteinaceous and non-proteinaceous. Proteinaceous is called as apoenzymes. Non-proteinaceous part is called as cofactor. Okay. And cofactor, remember, cofactor is very essential for the activity of the enzymes. If you remove the cofactor from a conjugated enzyme, the enzyme will not be functional. Remember this. Now again, a very important term, this term has been asked on numerous occasions. Simple enzymes plus cofactor is called as holoenzyme. What do you mean by this? Simple enzyme plus cofactor is called as holoenzyme. That means when a simple enzyme is present and a cofactor is present, that means when you are having the simple enzyme, that means apoenzyme, when the apoenzyme is present, you can call it as apoenzyme plus cofactor is called as a holoenzyme. Then when that means that when the proteinaceous and non-proteinaceous part are present together, or apoenzyme and cofactor are present together, it is called as a holoenzyme. This is again important. What is apoenzyme? What is holoenzyme? What is cofactor? What is coenzyme? What is metal ion? All of these questions have been asked at different levels. Now, understand this: cofactor can be connected to the proteinaceous portion. Proteinaceous portion means apoenzyme. That means the cofactor and apoenzymes are connected with a bond. Obviously, they will be connected with a bond. This bond can be of two types. It can be covalent in nature and it can be non-covalent in nature. Covalent bonds are strong bonds. Obviously, they are strong bonds. But non-covalent bonds are not so strong. Not strong. They can be said as weak bonds. So now we are dividing it on the basis of the type of bond through which the cofactor is attached to the apoenzyme. Now, the cofactors, as I've already said, cofactors can be divided into multiple types. They can be of simple metal ions, and they can be of complex organic compounds. They can be complex organic compounds and they can be simple metal ions. Simple metal, when I say simple metal ions, I simply want to say that they are inorganic in nature. Inorganic in nature. That means cofactors can be divided on the property whether they are organic or whether they are inorganic. If they are inorganic, they can be simple metal ions. If they are organic, they can be called as coenzymes. Now this is again a very important part. Now most of the coenzymes, that means most of the organic components that are linked to the apoenzyme, are vitamins in nature, are vitamins. Now that is why vitamins are essential component of your enzymes. If you do not have proper vitamins inside your body, your many enzymes will not be functioning properly and you would be suffering with some kind of disease or other. That is why having or consuming vitamins becomes an essential part. So vitamins, remember this. Transient association of coenzymes plus enzyme. Now depending upon the association time, this is time. That means if there is a transient association between coenzyme and enzyme. That means coenzyme was organic in nature. So if the association between them is transient for a very short period of time, then the coenzymes are also referred to as co-substrates. Okay, when there is an association between the coenzyme and the enzymatic portion or protein portion for a very short duration of time, very transient time, then coenzyme is also referred to as co-substrate. This is important. Again, this question can be asked. Next, when the coenzyme and enzymes have tight association, when I say tight association, I want to specify that the association will be there for a longer period of time. But they can be classified on the basis of the bonding. That means the tight association is there. The bond between the coenzymes and the enzymes, bond between them can be covalent bond and can be non-covalent bond. In both the cases, if the association is tight, remember that the coenzyme will be referred to as prosthetic group. Coenzyme would be referred to as prosthetic group. When will you say coenzyme as prosthetic group? When there is a tight association between coenzyme and the enzyme. Then you will call it as a prosthetic group. You might be, how to remember this? Now you might have seen people who do not have hands or do not have limbs, or they might have undergone an accident because of which they might have lost their limbs. So what happens is there are many companies which provide prosthetic limbs for such kind of individuals. Now obviously these prosthetic limbs will be attached to the system in a very tight way, otherwise the prosthetic limbs would be removed or can be taken off very easily. But logically speaking, the prosthetic group should be attached to the system in a very strong way. So same concept you can apply over here also. So the prosthetic group, or when the coenzyme is attached to the enzyme portion in a very strong way, with a very strong bond, in a very strong way, whether it is a covalent bond or a non-covalent bond, the coenzyme will be referred to as prosthetic group. But when the enzyme is in form of metals, obviously we said that metals are inorganic in nature, or they are called as cofactors rather. So they will be called as metal activated enzymes. Remember that metal activated enzymes will have weak association. They will not have a very strong association. So the cofactors over here are associated to the enzyme in a very weak fashion. In that case, you are calling it as metal activated enzyme. And in case of metalloenzyme, there is a tight association. So returning back to this, metalloenzyme is having a tight association. This is having a tight association. But in case of metal activated, this is having a loose association. So this is the difference. Okay. So I hope you would have got this clear in your mind. Metalloenzyme tight association. Metal activated is having weak association or loose association. Similarly, prosthetic group is having a strong association, things like that. Now, with this, we come to the end of the classification of enzymes. Now, let us move on to some of the PYQs, and I hope you would be able to do all the PYQs over here because I have taught you each and everything. Now, the first question that is present is, enzymes accelerate a reaction by which one of the following strategies? So obviously enzymes would be accelerating a reaction by decreasing the energy required to form the transition state. Decreasing the energy. I already said that the activation energy gets decreased over here. Activation energy is decreased. And activation energy is only the energy that is required to form the transition state. So obviously the activation energy would be decreased over here. If you remember the diagram that I had drawn in this case, you would remember this is the activation energy that we have decreased. This is the activation energy. This is the activation energy that you have decreased. Previously the activation energy was this much, and now the activation energy has further decreased. That is why we are saying that the activation energy would decrease. So this is the correct answer is decreasing energy required to form the transition state. The correct answer is first. Now let us move on to the next question. Enzymes, this was the first question. Now moving on to the second question. Enzymes accelerate rate of reaction by. Now, how would the enzyme accelerate the rate of the reaction? Lowering the activation energy of the highest transition state. Obviously, we saw that the activation energy is lowered down. So the highest transition state, activation energy to reach the highest transition state is lowered down, and this is the way in which the enzyme gets accelerated. Next, let us move on to the third question, sorry. Enzymes do not interfere with. I've already said that enzymes will not interfere with the reaction equilibrium, K equilibrium. So a K equilibrium is independent of the enzyme that you are using. Okay, so enzyme will have no effect on equilibrium constant. I have already said that. Next, this is question number 3. Let us talk about question number 4. Which one of the following is not a property of an enzyme? From complex with substrate, decreases activation energy, decreases Gibbs free energy. Now remember this, the correct answer to this is it decreases Gibbs free energy. Let me explain this to you over here. So what happens is, in case of an enzyme, delta G is not affected. Why I want to say that? Now you would be knowing that delta G can either be positive, it can either be negative, and it can either be 0. Now you would be knowing that the reactions that are having delta G value as negative, they are called as spontaneous reactions. Spontaneous reactions. Now enzymes will be taking part in only the spontaneous reactions. When the delta G value is positive, this reaction is non-spontaneous in nature. This reaction is non-spontaneous in nature. What do you want to say when you what do you want to say in non-spontaneous reaction? Non-spontaneous reaction means that they will be thermodynamically not feasible. Thermodynamically not feasible. That means these reactions will not occur thermodynamically. This is what happens when delta G value is positive. So remember that the enzymes will be always taking part in those reactions that are having delta G value as negative. That means thermodynamically feasible. Thermodynamically feasible. Okay, so that is what was asked over here. So it decreases Gibbs free energy. No, there is no effect on Gibbs free energy. Remember this. Whenever an enzyme is taking part in a reaction, there will be no difference in the Gibbs free energy. So what is a Gibbs free energy? If in this diagram, if I show you, the Gibbs free energy is actually the difference between the energy of the substrate and the energy of the product. This is the Gibbs free energy. And you can see that there is no difference in the whether you are taking a route of the enzyme or whether you are not using an enzyme. There is no difference in the Gibbs free energy. Okay, now hopefully you would have got this. Now let us move on to the next question. Fourth question we have done. Question number 5. Enzymes help to lower the activation energies of reaction by covalently interacting with the substrate. It's not always true. Binding only with the solvent molecules, changing reaction equilibrium. This is not also true. Forming weak interactions with the substrate. Remember that the substrate, when the substrate is interacting, let us say this is an enzyme. This is an enzyme. And you can see that this is a substrate. Let us say this is a substrate. Okay. Now actually what happens is the enzyme and substrate, they will be forming weak bonds between them. When the substrate approaches an enzyme, the formation of weak bonds will be there, and when these weak bonds break, there is this energy, the energy that is dissipated when the weak bonds will be breaking. This energy is used to bring down the activation energy. So this is how this is how the activation energy is decreased. So this was only asked in this question, that how does the lowering of activation energy is achieved? It is achieved by formation of weak interactions with the substrate. Always remember that there will be never there will be strong interactions with the substrate. Enzyme, if it is having covalent bonding with the substrate, the enzyme will be automatically inhibited permanently. Okay, why? Because covalent bond is so strong that the substrate will not be able to retract from there, and ultimately the enzyme will be poisoned or it will be inhibited permanently. Now let us move on to the next question from the following statements. Enzymes enhance reaction rates by a factor of 2 to 10. No, this is not true. Rate of reaction is achieved up till at the rate of 10 to the power 5 to 10 to the power 7. So incorrect statements we have to find out. So A obviously is incorrect. The activation energy of a reaction is lowered by the enzyme. This is correct. Interactions between the enzyme and substrate are hydrogen bonding, hydrophobic and ionic. Yes, these are all the non-covalent interactions. So obviously the substrate and the enzymes will be always interact with non-covalent interactions. Last one is substrate concentration does not affect the rate of the enzyme catalyzed reaction. No, it's not like that. Whenever you are adding more and more substrate, the rate of the reaction will be increasing. Yes, up till when all the enzyme molecules are saturated. If all the enzyme molecules are saturated and then you are putting in substrate, then there will be no increase in the reaction rate. But up till the enzyme molecules are still left or they are still unsaturated, you are adding more substrate, it will obviously increase the rate of the reaction. So this is true and this is wrong. So A and D statements are wrong. So correct option is fourth. So this was about the topic enzymes. I have a very important announcement to make. So we are currently running our GAT-B batch, GAT-B course. So those of you who are GAT-B aspirants and want to learn and want to prepare well, you can join our course, GAT-B course, and the contact number on which you can inquire about the course is 8299134528. The cost of this course is rupees 3500, and the plan is that we would be completing the course by the first week of April, and then we would be devoting all the time to solving all the previous year problems. In this way we would be revising all the material. So about the GAT-B course in detail, you can just check out, you can just search for GAT-B crash course on my YouTube channel, and you would be able to find out the recent video in which I have given all the details of the course. So hope you enjoyed the lecture. Do tell us how did you like the lecture, and also tell us what topics you would want to study next. Thank you so much. Have a good day.